Let's start working on our fluid connector. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. Before I start working on the fluid connector, there is something inside inventory connector that I totally forgot to do, and we need to fix that. In our base, we have two interfaces, iStorage connector and iStorage provider. Now you see that the storage connector is not implementing any of them. The storage connector is an interface that accepts a type and it will return the storage. The storage connector is actually another thing that returns the connector itself. Now, if you recall, I told you that inside the J inventory, I had this I inventory provider and I had to add this here. Well, guess what? They are identical. This is a storage provider combined with connector provider, and iInventory connector is just get inventory connector. iContent drop, I was debating on putting it inside the base, but then I noticed that we need the inventory connector, so that's not possible. And iConnector provider, we have duplicates of everything, isn't it? Because this is getting the connector, that's the storage connector, so bye-bye to that. Again, inventory connector returns the inventory connector, bye-bye to that. Those were duplicates of the storage connector, and iInventory provider, that's bye-bye. So inside our inventory connector, I need to say that it implements the iStorage connector. Now remember, this will return the connector itself, okay? Of type inventory connector, okay? Of type T. Then we need to say iStorage provider of something else. Now storage provider needs to return things for the sided map, and here we need the inventory storage, okay? And this tells me that, hey, implement methods for get connector, blah, 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 blah. Okay, let's see what we get here. Now, get connector should return this. The get storage provider is a totally different story. Remember, this will work when we have a sided inventory or sided storage, whatever. Because of that, we need to say we want to get the storage based on a direction, but the direction is not what we sent in, because we need a facing here, and I totally forgot that one. This is actually wrong because, yeah, we are working in multiple places, I know, because right now we are only accepting a direction, but at the same time, we need direction facing in both cases. And because of that, I need to accept a facing here. And what's wrong with you now? Oh yeah, because I didn't update the base on this library. Yes, I need to nuke my whole Maven local and start from base going all the way down. Anyway, now we say get a storage, and I want a single face. That is mapped direction, because we are working with mapped direction here, dot from direction. The direction is post helper dot get relative direction. I'm not sure if I have it or not. I will take a look. I think I have something like this. Block pause, direction left, back, relative maybe. Yes, relative direction. The name is changed compared to my notes. Then here we say mapped direction dot to direction, or actually, is it just accepting a direction? Yes, it only accepts a direction. So yeah, why not? Mapped direction dot to direction. Let's call it direction that we sent in. Okay, the direction. And after this, we want the facing. And what we had done here in this crazy math is that we get the relative direction of our direction based on the facing, and then we convert that to be a mapped direction and we get the storage. Okay, I'm not sure if I can drop this mapped direction thing here, but I will keep it. I will drop it if I can. I should be able to, because I have overloads for that. Now, in this case, it's easier. We say get a storage for a direction. All we are doing is saying post helper relative of the direction compared to the facing, get the storage, return that. Now for the use case of something like this, I have some things going on, although it's not updated, for something like wood stripper, I think. And if I look at block entity, you see these get inventory provided that accepts a direction. Here I say if the direction is down, please go into the direction and get the storage down. I'm not using that relative thing right now because it's not rotatable. In case of bucket filler, the provider here, get inventory provider, I say that again, go down. So I'm not using this relative calculation right now. The problem with this is that we can't directly assign the provider here. However, the use case would be something like this. By the way, this will happen in your block entity. Okay, so let's go all the way down. This is your block entity code. Okay, so we will have get fluid provider. This accepts a direction, and it will return a public single fluid storage. And this is where you will assign to the cited call of your block entities in your block entity registry. In our block entity, we know that, for example, we assign the fluid storage to be the up. So we can say our inventory or fluid container or whatever, get a storage provider from mapped direction.up and the direction that we sent in. That is the use case for these things. Instead of going for that crazy math check, we can do it this way. And this get a storage will return this cited map of things. And I think it will return, what will it return if it's not finding anything? It throws if the key is not there. Okay, now let's think. We are saying that we are on up side and it should be in our map. So retrieving the storage will work. However, we are rotating it, this will fail. Yeah, okay, I need to cover that case. So I will select all of this because this is the facing. And actually, I think I can say .var. So it makes a variable and I will say side and I will say if get sided inventories, that is our not list, that is a list. If this dot sided inventories, again, that's a list. Here is it, get sided map dot contains the key for side, then please return that, otherwise return null. That should work. And again, here I will say .var. Let's call it side. Again, we want that part. And then if not, return null. So are these nullable? No. Let's mark them nullable. And what are you yelling at me now? Side. May not contain key. Yeah, I'm just checking if contains key, you know? Oh, our map is a mapped direction. Yeah, so we say, yeah, you're right. So mapped direction dot from direction side. You happy now? And mapped direction dot from direction side. So this means that we are avoiding a crash, but at the same time, maybe we don't have the side. I'm not sure if it will work or not. And honestly, it is a little bit of a confusing topic for me when it comes to the facing blocks. We will cross that bridge when we are testing it in our main mod. Anyway, so this is the get storage provider. And honestly, can I put this inside? No, because here we don't have the concept of the mapped side. Okay, implement methods, get the storage provided. Oh yeah, because I need to update my libraries. Okay, let's go back to the fluid connector thing. Fluid connector. The fluid connector is almost identical to inventory connector. However, there is this tiny mini difference. We have this storage connector. It adds our storages. It gets the storages. It gets the sided map. It gets a single storage based on index or direction. In our fluid storage, we don't need to overwrite any of this. At least I think so. However, in the case of inventory, things were different because the storage is inventory storage. However, the inventory is simple inventory. And that was a confusion there. And we had to add our lists and things like that. In case of fluid storage, thankfully, things are much simpler compared to there. What we need here is to write our fluid storage. First of all, we need to write our fluid connector. So we call it fluid connector. And this fluid connector will be extending. Actually, I need to give it a type. So T extends the storage of fluid variant. And finally, we extend it from storage connector. And remember, this needs a storage. So we sent in the T. Now it says that please implement methods for write NVT and read NVT. Then we want a combined storage, so private final combined storage of fluid variant and data storage. We call it combined storage. It will be new combined storage of this dot storages. And thankfully, it's coming from the top, so we can use that. Then we want a getter for that, so get combined storages that returns the combined storage. We need a constructor here, so we say generate a constructor public. Actually, we don't need a constructor because this should handle everything for us, and even this doesn't have a constructor. So the inventory connector didn't have a constructor. Yes, we don't have a constructor here. So we will have a public that returns a list of fluid stack, and we call it get fluids. This one should return all the fluids we have in the storage. So we say list of fluid stack payload, and we call it fluids equals to new array pay list. And then we say this dot storages dot for each, we go into the storage, we say storage dot non-empty views dot for each again. So now we get each fluid inside our storage, and we call fluids dot add the new fluid stack payload with the fluid that we got, get resource and the amount. And it should do everything with a semicolon there, with a semicolon there, and at the end we return the fluids. Okay, what is going on here is a little bit confusing. I think I have covered it so far in the library series, and I will definitely cover it in the main series, but let's talk about this views. In case of inventories, we have inventory storage, and then we have simple inventory. In this case, we have storage of fluid variants, and these views are those simple inventories sitting inside this storage. In other words, the names are a little bit confusing, but we have a storage that has inventories. Each inventory is containing fluid. That inventory is called views in the case of fluids. Then when we got our hand on the content, we can get the variant. However, I'm not sure why they called it resource instead of variant. So this is the variant. They could have called it get variant, but instead they called it get resource, and I am not a developer of Fabric API. Otherwise, I would think of better names compared to resource and views, but this shows you the importance of naming your API. It is what it is. I can't handle Fluid API name changes, so we have to work with that. Anyway, what we are doing is that inside the storages, we are looking at any storage that is not empty. We collect them, then we loop through each of them. We get a storage, and inside each storage now, we look at its content, basically quote unquote, its inventories. And we say that, hey, any inventory that is not empty, think of it as this. This is the inventory. This is easier to understand. This is the inventory. This is the stack, okay? The item stack. So in this case, this is the fluid storage. This is the fluid view, okay? Anyway, we say that, hey, inventory, please give us any view that is not empty. Basically, we are saying that, hey, please look into yourself, collect every fluid container that is not empty. Then loop through them and get one fluid container at a time. From that fluid container, get the resource and get the amount. If I change this name to be fluid container, it may become easier to understand. Basically, that's what we are doing. We are adding them to a list, and finally, we get the whole list out. Finally, the most important ones, write and read NBT. This is the heart of this method. We are returning an NBT list, by the way, because we are extending the storage connector, and the storage connector is implementing iNBT serializer. That is why we are seeing that read and write NBT returning lists. So here we say var list equals to new NBT list. Then we say this dot storages dot for each storage, we want to say if the storage is instance of not fluid variant, but single fluid storage, we call that one single fluid storage. If that's the case, we can continue. Basically, we are not handling multiple fluid storages right now. So we say var NBT, actually let's use the proper naming, NBT compound, NBT equals to new NBT compound. Then we say NBT dot put long, and for the key, I think I have constants that I can use in the base. Let's take a look at my constants, and that is BE keys. Unfortunately, it is using dot there. Okay, let's go with the amount. So amount, it's not hurting anyone. The reason it's unique is that we are putting it inside our own compound and not in the general compound of the block entity anyway. And then we say single fluid storage that get amount. That's what we want. Then we say nbt.put. Now here is the variant. So we say not the capacity, god damn it. nbt.put. We call it fluid. This is the variant. Okay, so we say fluid variant.codec.encode the single fluid storage that get resource. And then we want to assign the operation here, and we say nbt ops.instance, so it knows that we are using nbt here. And finally, new nbt compound. Before the last parenthesis, we say dot get or throw. Now, what's going on here? A fluid by itself, a fluid variant, is a complex data type. So we need to put another NBT compound there so that it will combine itself into a compound and then put that compound as a fluid name inside this compound. So we are inserting one compound into the other one. We are using the NBT operations here. Now, this get or throw is actually happening here after the fluid and get encoder, because get encoder will give us a data result and not a data. So we need to use get or throw so that when we get the data, we can handle that. And if the data is corrupted for any reason, it will throw an exception there. Okay, now that we have the NBT, finally we can say list.add the NBT. We go all the way out of this loop, and here at the end we return the list. That is the writing of NBT. Now, instead of using for each, of course, we could use the classic for each, I don't know, storage inside our storages, but I like this way of writing it. Don't worry, it doesn't have anything to do with performance hit, because the compiler will compile both of these two to a single machine code. So there's no difference there. Now, for read NBT, the thing is that we don't know the size of the NBT element, and let's rename this guy to be NBT. We are not sure how many things we have so that we can use for each. Instead, I will type for I and hit enter. So it will write a normal for loop for me. I will rename this to be index, and the index needs to be smaller than nbt.size. So we get the size like this. And now we can start reading our NBT. So we say NBT compound, we call it compound, equals to the NBT.get compound or empty for the index. So we say that, hey, if you have a compound, give us the compound, otherwise return empty compound for us. Then we say the type T, that, remember, it's a fluid connector. Here extending a storage fluid variant. Storage equals to this dot storages dot get at the index. So we retrieve that storage from our list. And then we can say if storage equals to null, then we continue because we don't have any storage at that slot. However, if we have the storage, we can assign values to it now. So we say if a storage instance of a single fluid storage, do things else, please throw new unsupported operation exception. Why not? Please provide a meaningful thing for me. Unsupported storage type of storage get class dot name. That's properly coded. And then we say single fluid storage dot amount equals to compound dot get long. Make sure that you have no typos there. So I will use copy paste. And if it fails, we can have a callback. The callback will be 0 long. So if we don't have any amount, please make it empty. And then single fluid storage dot variant equals to the fluid variant dot codec. We decode it. For decoding, you see that the first overload is asking for dynamic operation, and we know that we used nbt ops.instance, so we use the same thing again, compound.get, and here we use the name fluid. Now that we have data result, we need to map it. So we say dot map, and you see that it asks for a function that is pair, and it simply say pair colon get first. Means that get the first one, put it in the slot, because it will remove it from the nbt compound, then it will loop and get the other ones. Finally, get or throw, and this will read all of our storages from our nbt and put them properly in place. This write nbt and read nbt are nothing simple. Well, they are not that complex, but they are not simple. The reason for having a fluid connector like this is to avoid copy pasting it or writing it over and over and over, because when you do repetitive job, you open the door for errors. Now, in my notes, I have a few other things that I may want or I may not want. Let me take a look. So this is my notes, by the way, so that you know I have things not exactly as Turti is doing, because the code that is commented is exactly the same and identical. And yes, I have this combined storage too, but you see that I have some things that is not provided by Turti. For example, get the amount, get the capacity, get type based on the index or the direction, and then get the storage. Now this is exactly, I think it's identical. There are minor things that we have different. And by the way, this code was for 1.21.3 3 and 4. Things has changed in 5, so it's not usable anymore. Anyway, let me comment them. Same goes for the read NVT. This is the old way of doing things. You can pause the video and write them if you are working on lower versions. I highly suggest that you should stick with the updated versions of Minecraft all the time. Anyways, now I have this get provider and get provider here. So let's start with my notes from top to bottom. I can have some set methods. Now I had done it inside the inventory connector too. If you see, I have these add inventories, and these 3 or I don't know 4 or 5 provided by Turtivorti, but then I have these that accept factories. It makes my life much easier at times. Inside of our fluid connector, I will add few. Maybe behind the scenes I will add the factory ones. So we will have a public void add synced storage that accepts a block entity, and then long capacity. This one we'll call the add storage for a block entity, and then capacity, and then mapped direction dot none. We need to have that overload. It accepts a mapped direction. Now why are you not happy? Add synced I should call. Here we say add storage new synced storage, and this guy is asking for the block entity, so it's block entity, and then the capacity would be the capacity, and the map direction would be the direction. I think synced fluid storage is not accepting the direction, isn't it? No, I got what I'm doing wrong. The direction should go out of the here. Okay, now what's wrong with you? Add the storage is asking for T and map direction. Oh, T. How did I do it inside the inventory connector? Oh, these are the things that I'm doing here. This is why I have these. Basically, I can't have a direct call for anything like this because we are adding the storage based on T on the superclass, and we can't handle that here. Simply the synced fluid storage is not exactly the T. Okay, we are not sure if it's T or not. We need to have the ones that is accepting the block entity like this. It's a bifunctional of, oh, look at here. Look at here. I'm accepting directly my type of block entity. However, it should be any block entity because the superclass is handling the block entity dirty and syncing and everything else. Come on, import a class. So I need to fix this one fast, and it's not generic anymore. So this guy will be this. Let me handle this, and we will go back and talk about how we can utilize and change this thing very fast and smoothly. Okay, and the ones on the top for the simple and recipe are okay. What we need is the block entity, the size. That would be the first overload. So copy this and go back into our fluid connector, paste. Of course, now we need the one. What's wrong with you? Add inventory, add the storage, I should call it. Anyway, there we go. The other one is accepting a map direction and then a direction. Now these 3 will be not used because they are dedicated for item stacks and we are not having them. That's it. And these are add the storage here and here, and it will work. Now inside here, I will rename every add inventory. Should I keep it as inventory? Because we established the fact that all of these are storages and I want to be consistent. So now that I have to overwrite all of my Maven locals, why not change this guy to be storage? That's one thing. And inside here, whenever I have add inventory, I will hit Control R, Control C, tab, Control V, and I will change it to the add storage so that I will be consistent, you know, and replace all, please. Add a storage, because if I'm working with different connectors, I know that all of them are connectors. So in each connector, I want to call the same method name, not different method name based on the type of the connector. Consistency is a good thing. And inside here, again, all of these should be add storages. Now these will let me have something like this. I can say add a storage of the block entity, comma, the size, comma, the synced fluid storage, colon, new. As simple as that. And it should work. Why are you yelling at me? Interface of by function TUR cannot convert synced fluid to T. That's okay. Basically, it's again conflicting with this guy on top. But this is the use case. This is the factory. Because I'm using T here, that is yelling at me. However, I can simply now call the synced fluid, or I don't know, the output fluid storage or the input fluid storage, just like that. And it's much simpler. For the predicate one, I can't have that. So for predicate one, I need to directly use that add a storage on top and add my own storage with the directions. And you see that here I'm using that add a storage name and get a storage name. So inside inventory connector, it's important now to double check what I'm getting. Get inventories, return a list of T. T is simple inventory. And then do we have get storages or get the storage? We wouldn't have it there. What I'm doing, it's already there. So get the storages, yeah. Okay, I'm derping. Now that we have that, our fluid connector, it's done. And the only thing that I want to add now is some overloads that will make my life easier. For example, public that returns a long, and I will call it get amount for the mapped direction. Now all I will do here, I will say return get a storage on the direction, and then from there I can say get, oh, let's look at that. Okay, I have a problem here. Get a storage dot, oh, it's the storage. I don't want to iterate through it. Oh, god damn it. What I was doing here, I'm get a storage myself. And by the way, I'm looking at my notes. Let's see it together. We have the map and this get a storage. All of them are calling this guy. If direction, this dot storage that get first. Storages. Oh, what? That doesn't look nice. Oh, it's if it's null, then it's the first one. Other one, the side of the storage. Yeah, okay. We are calling our overloads anyway. So we will deal with that. So we get this from the direction and then we call get amount. Then we have public long get capacity for the mapped direction. And here we say return get the storage again for the direction dot get capacity. We want the variant public fluid variant. We say get variant. I'm changing the name right now on the fly. Mapped direction. Here we say return get the storage of the direction and then dot get resource. And we already know that we are working with views here. Then we go with the index for these things. So instead of direction now, I have int index. So I will send in the index, again index, and here should be index. Of course, I can use the direction. In my notes, I didn't use that. So let's first of all fix those errors. So we say public single fluid storage, get a storage based on the map direction, and you see that immediately 3 of those errors are gone. So if the direction equals none, then we go with return this dot storages dot get first. That means that we just return the very first thing. And what are you yelling at me? It says that cast expression to single fluid storage because it's list of E and the storages are list of T. So we return actually T here, and we're back to day 1 because get amount is what? What do we have now? Dot. I want the view, you know? Actually, it was there. I don't need to do that. I want the view. How can I retrieve the view from a storage of fluid variant? We have iterators. I hate iterators. Let me see. Do we have anything that we can use? We need to go back to our storage connector. So get storages are already returning T, and we don't have anything here that covers that. All of them are just storage of item variant, and that means that they have iterators. The problem, the actual problem, is that fluid storages are not like item storages. Here we have a storage of fluid variant. This changes things a lot, and I mean it, a lot. In my notes, I had a list of single fluid storage. Let me show you. I have this list of single fluid storage, and when I was adding any storage, I would add it to the list. And because of that, I can retrieve them based on that thing, because again, my map is map of mapped direction with single fluid storage. So instead of a storage connector of our storage, how about I say single fluid storage? Now I will have a problem here because it is accepting of T. It should accept single fluid storage. It will solve that one. Oh, look at that. Yeah, we can't do that. So a storage in a fluid container can have more than one fluid variant, and that is the problem here. Let me stop the video here because because it's getting long, and let's talk about this problem in the next video.
If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.